exclusion principle. Say it again. Paul's exclusion principle. Say with power. Paul's exclusions or Paul's exclusions principle. So the fundamental question which you will find in midterm testing, terminal exams, in annual exams, in mock exams, in pre-mock exams, will ask you that to state what? State the Paul's exclusion. We have X here, excuse me. Paul's exclusion. So exclusion principle. So you as a chemistry state the Paul's exclusion principles. This is the way that it is stated. So it states that, I would like to quote, state that no two electrons, right? This is all about the rules, the Paul's exclusion rules actually that is telling us there is no any two electrons that have all the four quantum numbers. That's all. Since it's not possible for the two electrons, for example, these two electrons, it's not possible for these two electrons to have the same principal quantum number. Why? Because to have the same quantum, or to have all the four, or the same four quantum numbers. The principle, the Paul's exclusions principle. So Paul's exclusion principle tell us about the relationship between two electrons and the quantum number, right? How many quantum numbers do you have in chemistry? 4. So no any two electrons in the same energy level, in the same orbital, yes, because of in the same orbital in different orbitals, which have the same 4 quantum numbers. They might have the same 2 quantum number, or 3, maximum is 3, but it's not possible for 2 electrons to have the same 4 quantum number. And the one that which is going actually to be different is spinning quantum number. These electrons, they have the same principal quantum number, right? N is equal to what? 1. And when n is equal to 1, what the value for subsidiary quantum number L is equal to 0. So 0 is a subsidiary quantum number for these electrons and also for this electron. Chemistry is beautiful. So you find that these 2 electrons have the same subsidiary quantum number. And then the said quantum number is magnetic quantum number. So how do you find magnetic quantum number? We say negative L to 0 to positive L. So our L is 0. So magnetic quantum number is equal to 0. So these electrons has magnetic quantum number equal to 0, and these electrons has magnetic quantum number equal to 0. So they have the same theoretic quantum numbers. But now in case of spin quantum number, they don't have the same quantum number, the same spin quantum number. Why? Because this is positive 2 and this is negative 2. Do you know why? Because that when you place electrons in the same direction, for example, if you say that these 2 electrons, they should have the same spin quantum number, then we increase the tendency of repulsion between electrons. So filling electrons in these directions will reduce the tendency of repulsion. Why? Because electrons are negatively charged. So like charge, repel, and like charge, attract each other. Chemistry is beautiful. Okay, no 2 electrons in the same atom right, in the same atom can have what? The same the same 4 quantum numbers. 4 quantum numbers at the end of quotation. So according to this form of Paul's exclusion principle, the 4 quantum numbers act as a fingerprint or signature of an electron. Okay? So before maybe I write this sentence, we say that Paul's exclusion is satisfied by the fact due to the repulsion between electrons, 2 electrons in the orbital must be spin in opposite direction. Okay. We say, for example, let me explain this principle first because I want you to understand. I spent a lot of energy understanding this material when I was in A level, and even I suffered a lot to understand the truth. The cream is not a problem. So, what are the electron configurations of carbon? Remind yourself, 1s square, then you say that 1 what? 2s square, and then you have 2p square, right? 2p square. So you say that if you write by using the box method, here you have 2 electrons. Here you have also a pair of 40 of electrons, right? And then here you have unpaired electrons. So this principle is defining the 2 electrons, not the 1 electron. So it's dealing between these 2 electrons and these 2 electrons. So listen. So the principal quantum number here is equal to 1, right? The subsidiary quantum number is equal to 0. You remember that? And also both of these electrons also, they have the same magnetic quantum number, which is 0. But the spin quantum number, ms, the spin quantum number is not the same. Why is not the same? Because positive a half is not equal to negative a half. Similarly, the principal quantum number here is what? N is equal to 2. So they have the same principal quantum number. The subsidiary quantum number here, we have 2 subsidiary quantum number. L is equal to 0 and L is equal to 1. But the s orbital is always found when L is equal to 0. Right? So when L is equal to 0, M is equal to 0, means magnetic quantum number is equal to 0. Yes, magnetic quantum number is equal to 0, but the spin quantum number is not the same. Okay? So that's about Paul's exclusion principle. Use these examples, you won't spend much time on learning these principles. Right? Okay. So is that the case? So we have a question. We have a fundamental question before we go to the fourth principle. Okay? And this is the question now. I would like to, so you say that that's according to this form. So we say that according to the alpha of according to the Paul's exclusion rule, say that the electrons, not the electrons, say that the 4 quantum number, the 4 quantum numbers acting as the fingerprint. Say fingerprint. You know that we don't have the same fingerprint yet. 6 billion people in the world, we don't have the same fingerprint. So this acts as a fingerprint or signature. Signature 40 of electrons. So signature gives us unique identification. Okay, so we have a fundamental question which is similar to these homework questions. Remember to copy this homework question. Okay? Okay, thank you, copy it. The second question in your homework is this. If you go through this lecture, I have answered this question, but I want to notice if you are serious in listening. So this is homework 15.2. Question is this one. So this is question 2. Explain briefly. Okay, explain briefly, because I have to test you these questions. Why the 2 electrons, in the same orbital, are filled in opposite direction. So explain. So answer this homework and you can submit your homework in the comment section. All the homeworks, the answers of all the homeworks, you have to submit them in the comment section to be reviewed. Okay, so explain briefly why the two electrons in the same orbital are filled in opposite direction. So if you answer that question, we say that the rules of writing electron configurations are like rules of arranging candles in apartments. That's not a great deal. Let us now go to the fourth and the last principle of writing advanced electronic configuration. It's called what? You remember it? It's called the full and the half full. So full and half full principle or rule. So we have two rules and we have two principles. Right? The fundamental question is this one. Okay? So you say that state what? State the full and the half full role of electrons. So this the way that it states. It's a little bit tough to understand the way it states, but I will try my level best, and I'm praying that God will help me to explain to you. It states that for D, this is the rules that guiding D and F sub-energy level, for D and F sub-energy level, but we use the word sub-energy and the orbitals interchangeably. Orbitals, the full or half configuration, the full or half configuration, the full or half full or half full configuration, configurations in the subshell. In the subshell. The subshells are very stable. A very stable configuration with minimum energy. Configuration with minimum. At the end of the state. So for D and F orbitals, rules state that for D and F orbitals, the full, listen carefully, the full or half full configuration in the subshells are very stable configuration with minimum energy. For which orbitals? For D and what? And F orbital. The full, say full, the full or half full configurations in subshells are very stable configuration with minimum energy. His research based on what? On the orbitals, and see what are the conditions required for the orbital to be stable, right? So he discovered that for D and F orbital to be stable, right? They should be full filled or they should be half filled. Interesting. Do you understand? What does it mean? Think a minute, take a minute to think about this rule. What do you get? Which information do you get in your mind before I clarify to you by using the box method so that you can enjoy and relate into the previous lecture so you enjoy the beauty of principles of advanced electronic configuration. This signifies that now you are in advanced level. You are no longer in ordinary level. So listen carefully. The rules discuss about what? Two orbitals, D and what? F orbital, right? So let me clarify. So this is clarification. Say clarification. This is clarifications, or we call it revelation, right? So this is clarifications and revelations. When I was preparing this, when I thought about these rules, no one in a book that explain in details what does it mean, but I got revelations which is helpful for you. Are you ready? Are you ready to accept that revelation? Good. Let us start with D orbital. Say D orbital, or D sub-energy level. So let us call it D sub-energy level, right? So let us refer the previous lecture. How many orbitals does a D orbital has? How many? How many orbitals does a D have? I told you it has how many electrons? How many orbitals? 7. How many? S orbital has, S sub-energy level has 1 orbital. P sub-energy level has 3 orbital. D sub-energy level has how many? 5. What? 5 orbitals. So D sub-energy level has 5 orbitals, right? Because it has 5 orbitals, what is the maximum number that the D orbital can occupy? Of what the maximum number of electrons it can accommodate? Can accommodate 10 or 10 electrons, right? So listen, if the D sub-energy level is filled with all the 10 electrons, then it is stable. Or when it is half filled, what is half of 10? 5. So it means that the D sub-energy level, sub-energy level is stable when it contains what? When it contains either how many? 5, which is half fulfilled, or what? Or 10. What does it mean? Enjoy the beauty of chemistry. This is the box method, right? So the first case of 5 electrons, we have 5 orbitals. These are the 5 orbitals, right? 1, 2, 3, 4, 5. So this is D orbital. So if it contains 5 electrons, all the orbitals are what? Half filled. So this is stable. So this is stable D orbital or sub-energy level. Right? Okay. Because I gave you 2 questions on the homework that also clarify the Hans rule. Okay, Hans rule. For the what? Hans rule. No, not the pole. The full and half fill. The full and half full rule. So again, the stable D orbital will be stable when all its orbitals are either half full or full. How many orbitals are there? 5. So if we fill electrons according to the Paul's exclusion principle, according to what Hans rule. This is the first principle, right? According to Hans rule. And then we start pairing this lowest sub-energy level, next sub-energy level, next sub-energy level, next sub-energy level. So how many electrons does it have? 10 electrons. So when it contains 10 electrons, it is stable. So for example, if D orbital contains how many electrons are there? 2, 4, 6, 8, 9. This is unstable d orbital. That's all. That's all about full and half full rule. Beautiful rule. Okay? So that's all about the d orbital. Let me explain for the f orbital, because you can say that, Olenjolai revealed the secret in f orbital in d orbital because it's simple. So even himself, he doesn't know about f orbital. Okay, f sub-energy level, right? I told you in previous lecture, has how many orbitals? Has 7 orbitals, right? 7 orbitals. So if it has 7 orbitals, its maximum number of electrons, accommodated in F sub-energy level is how much? 14, right? So if it's 14, it means that the stable F orbital will be in this form. A is a half full fill, first orbital, second orbital, third orbital, fourth orbital, fifth orbital, 1, 2, 3, 4, 5, 6, 7. So the stable F orbital is if it is half filled. So it contains how many electrons? 7 electrons. This is the stable F orbital. And as a stable F orbital is if it is what? All the orbitals are full with electrons. So this one, this one, this one, this one, this one, this one. So we have this, we have this, we have this, we have this. But you have to follow Hans rule first. You have to fill 1 electrons. Then remains is enough electrons to occupy to pair each orbital. Right? So that is stable. For example, unstable, because you say that, okay, not stable F. How about unstable? You might not be confident enough. So 1, 2, 3, 4, 5, 6, 7. So for example, if you have the F orbital filled like this is unstable. According to it, full and the half full rule. And that is the end of 40 lecture or session period 15. I believe you enjoyed. Myself that I enjoyed the beauty of the 4 principles regarding on writing advanced electronic structure. First of all, I give thanks to my Father who is in heaven, who is my own God, faithful to me. He gave me a chieftain to teach advanced chemistry and even some other advanced subject. Really, I have to thank you because you know that the protocol I found when I was in A-level studies, and the protocol is like this one. I did it the PCM. I did it the PCM at A-level. It means physics, advanced chemistry, and advanced mathematics. So I found a belief that all the students, previous students, even ourselves, even in our class or even the next classes, there's a spirit used to say that if you take PCM, you take physics, chemistry, and mathematics, many of the students who doing this combination of the subject at A-level, they used to be good in physics, in advanced mathematics, not in advanced chemistry. So they are very weak in advanced chemistry, and I proved that theory is true because they have a mindset that the advanced chemistry is not applicable for their future life because they expect to be engineers. That is wrong belief. If it is in your mind or that seed has been planted, please uproot it. Because myself, I did it, and I thank God by His grace. I mastered the advanced physics, I mastered the advanced chemistry, I mastered the advanced mathematics, and also I mastered basic applied mathematics at the same time, and I was not even confused. So for the PCB, the belief that we found when we went to A-level is that at the PCB, because they're expecting to be pharmacists or to be doctor of medicine or to be nurses or to be, let's say, veterinary medicine and so forth. So they have a belief that they are competent in biology and chemistry, and they are very weak in physics because they won't apply physics in their advanced studies. I don't think that the fact is true, because the government or the educational systems designed and having that combinations has particular visions. And even if you go to many Americans and even Europeans and Asians universities, regardless of what course are you studying, in the freshman year, you used to study physics, chemistry are the fundamental subjects. So they are useful in any field that you are going to study. The material that we covered in A-level mostly are covered in most of the university, exam, MIT or Harvard at the first year freshman, because they want all the students to have the same standard or the same level of knowledge before they pursue the second, third, and fourth year in the years of engineering. So that's why I thank God really, because He gave me His own favor, and really He loved me. He gave me something that which has been hidden, because when I was learning, what I taught you is almost 80% of the mistake I did myself when I was in A-level secondary schools. Nobody who taught me in this simplified way. I'm not boasting myself, but just I'm telling you something which is hidden, which I can take time for you to see, but myself I see, because I remember myself how I was when I was in A-level studies, and how I was when I began to teach A-level students 10 years ago, and even how am I teaching right now. So a lot of things have changed, and even the beauty of chemistry, or the way that I used to teach, is quite different. So I thank God for that. It's not because I'm very intelligent or whatever, no. That's the grace of God, and that's the God that I believe who lives, the Most High God. His name is the God of Abraham, God of Isaac, and God of Jacob. So I convince even yourself that if you don't know that God, you can start relationship, and He will bless you abundantly. So thank you very much. I'm waiting you to meet with you in this lecture or sessions 16, when we'll be now learning the methods of writing electronic configurations of the atoms, of the ions, of excited atoms. So we have a lot of things to cover. And not only that, but in future lectures also I'll teach about the chemical bonding, and you'll enjoy the beauty of chemistry. So stay tuned. Make sure that you have subscribed. Make sure that you share this material with your friends or with your classmates, and then don't hesitate yourself to join me in the next lecture. I'm praying for you, pray for me. May God bless you. See you in the next lecture. Bye-bye.